What if every thought you've ever had didn't just stay inside your head? What if it actually reached out and touched the universe? Picture this: the atoms around you, the stars above, even the fabric of reality itself, bending ever so slightly in response to your awareness. It sounds like science fiction, but some of the brightest minds in quantum physics and philosophy have spent decades wrestling with this very idea, that consciousness might not just observe reality but actively shape it. Welcome to one of the most thrilling and controversial questions in modern science. Does consciousness collapse the quantum wave function, weaving the universe into existence moment by moment? Think about the last time you looked at the night sky. Those stars you saw, some of them might not even exist anymore. Their light takes years to reach us, and by the time it does, the star itself could be long gone. But here's the twist: quantum mechanics suggests something even stranger. Until you observe a particle, it exists in a haze of possibilities, a superposition of all potential states. The moment you measure it, that haze collapses into a single, definite reality. Now, stretch that idea to its limits. What if your observation doesn't just reveal reality but creates it? What if the universe, in all its vastness, is waiting, literally waiting, for conscious beings like you to bring it into focus? This isn't just abstract theorizing. Cutting-edge experiments are probing the boundary between mind and matter, pushing us to rethink everything we know about reality. From the double-slit experiment's bizarre results to the debates between Einstein and Bohr, from ancient philosophies to today's quantum computers, we're standing at the edge of a revelation that could redefine what it means to exist. And that's exactly what we're diving into today. Together, we'll explore the wildest theories, the boldest experiments, and the profound implications of a universe that might not just be seen but shaped by the act of seeing. If that doesn't send a shiver down your spine, just wait, because what comes next will challenge everything you think you know about the world, and maybe even your place in it. Let's start with a simple beam of light. When you shine it through two narrow slits onto a screen, you'd expect to see two bright lines where the light passes through. But that's not what happens. Instead, you get an interference pattern, a series of dark and light bands, as if waves are overlapping, cancelling and reinforcing each other. This makes sense if light behaves like a wave, but here's where it gets weird. When scientists tried shooting single particles of light, photons, one at a time through the slits, the same interference pattern eventually emerged. How could a single photon interfere with itself? It's as if each photon passes through both slits at once, existing in multiple states until it hits the screen. But the real shock came when researchers placed detectors to observe which slit each photon actually went through. Suddenly, the interference pattern vanished. The photons stopped behaving like waves and started acting like particles, leaving just two bright lines on the screen. The mere act of observation of trying to pin down the photon's path collapsed its wave-like behavior into a single, definite reality. This is the observer effect in action, and it's not limited to light. Electrons, atoms, even molecules exhibit the same bizarre duality. When unobserved, they exist in a haze of possibilities. When measured, they snap into focus. Now, here's the million-dollar question. What counts as an observer? Is it the machine recording the data, the scientist analyzing the results? Or does it require something deeper, conscious awareness itself? Early quantum pioneers like Niels Bohr argued that measurement devices were enough to collapse the wave function. But others, like John von Neumann and Eugene Wigner, pushed further. They proposed that consciousness, the subjective experience of observation, might be the ultimate trigger. If that's true, then reality isn't just something we discover. It's something we create moment by moment through the act of perception. This idea blurs the line between the observer and the observed in a way that still rattles physicists today. Imagine holding an apple. Classical physics says it exists whether you're looking at it or not, but the quantum view hints at something stranger. that without observation, the apple's very atoms might remain in a fuzzy, undefined state. It's a radical shift, suggesting that the universe isn't a fixed stage but an interactive performance, with consciousness playing a starring role. And if that's the case, then the next logical step is even more mind-bending. What happens when no one's looking? Does the universe just pause, or does it need us to keep it running? So what happens when you take the observer effect to its most radical conclusion? That's where the von Neumann-Wigner interpretation comes in, a bold idea that doesn't just place consciousness in the audience of the quantum theater, but puts it center stage as the director. John von Neumann, a mathematical genius who shaped modern quantum theory, and Eugene Wigner, a Nobel Prize-winning physicist, didn't shy away from the unsettling implications of their own equations. They asked, if measuring a quantum system collapses its wave function, what or who actually counts as the measuring device? Von Neumann traced the chain of observation step by step. When you look at a particle, your eye doesn't collapse its wave function. The light hitting your retina doesn't either. Even the neurons firing in your brain could be described as quantum systems in superposition. So where does the buck stop? His answer was as elegant as it was shocking: consciousness itself. To von Neumann, the infinite regress of measurements measuring measurements had to end somewhere, and the only logical endpoint was the observer's subjective experience. Wigner took this further, arguing that even the friend standing next to you in the lab can't collapse your experiment's wave function, because until you become aware of the result, their entire mind could exist in a superposition too. Think of it like a dream no one remembers. If a tree falls in a forest and there's no consciousness around to hear it, does it make a sound? The von Neumann-Wigner interpretation whispers, maybe not just the sound, maybe the tree itself remains in quantum limbo, neither fallen nor standing, until a mind perceives it. This isn't just philosophical pondering. Wigner designed thought experiments to test this, like his famous Wigner's Friend, where two observers could theoretically disagree about when a quantum system collapsed, challenging the very idea of objective reality. Critics call it consciousness mysticism, but supporters point to its brutal consistency with quantum math. After all, every experiment we've ever done to probe reality's foundations has one thing in common: a conscious observer at the end of the chain interpreting the data. Even the most advanced quantum computers rely on human minds to read their outputs. So here's the real kicker: if consciousness does collapse the wave function, then the universe isn't just participatory, it might be personal. Your awareness could be the loom weaving the fabric of reality, thread by thread, decision by decision. And if that's true, then the next question isn't just about physics, it's about what happens when billions of conscious observers try to weave the same universe at once. Now let's bring a cat into this quantum puzzle, because what's stranger than a thought experiment that hinges on a feline's life or death superposition? Schrödinger's cat, locked in a box with a vial of poison triggered by a quantum event, is the ultimate metaphor for quantum ambiguity. According to the math, until someone opens the box, the cat exists in a bizarre limbo, both alive and dead, a fuzzy blend of possibilities. But here's where consciousness barges in. Does the cat's fate crystallize the moment a Geiger counter clicks, or only when a person finally peeks inside? The original point of Schrödinger's setup was to show how absurd quantum theory sounds when scaled up to everyday objects. But some researchers flipped the script. If tiny particles stay in superposition until observed, why wouldn't larger systems like a cat follow the same rules, dive deeper, and the stakes get existential? If the poison's release depends on a radioactive atom decaying, and that atom stays in superposition until measured, then the cat's entire reality hangs in the balance of observation. But here's the twist: what qualifies as a measurement, the Geiger counter, the box itself, or does it take a conscious mind to finally tip the scales? This isn't just academic hair-splitting. Imagine a version of the experiment where the box is monitored by an AI, recording data without any human ever seeing it. Does the cat's wave function collapse when the AI observes the result, or does it stay suspended until a person checks the readout? The answer could redefine the boundary between mind and machine. Supporters of consciousness-driven collapse argue that AI, no matter how advanced, lacks subjective experience. It's just another link in the chain, not the end point. But skeptics fire back. If consciousness is truly required, then the universe's reality would depend on who or what is looking. Picture this scenario. A scientist in Tokyo opens the box and sees a living cat, while another in New York, unaware of the result, still considers it both alive and dead. Is the cat now in two states at once, split across observers? This version of Wigner's friend for Schrödinger's cat exposes the cracks in our assumptions about shared reality. It suggests that without a shared act of consciousness, there's no guarantee we're all experiencing the same universe. The implications ripple outward. If observation creates reality, then every unobserved corner of the cosmos might exist in a quantum haze, waiting for a mind to bring it into focus. So where does this leave us? Either consciousness holds a unique power to shape existence, or we're missing a deeper mechanism that explains why some things collapse waves and others don't. The cat, meanwhile, remains the perfect paradox, both a critique of quantum theory's wildest claims and a doorway to its most profound possibilities. Whether it's alive, dead, or both might not just depend on the box, but on who's brave enough to open it. If consciousness really does collapse the quantum wave function, then what's stopping the entire universe from dissolving into chaos every time we blink? That's the question at the heart of the decoherence theory, the leading alternative to consciousness-driven collapse. Here's how it works. Imagine a single electron suspended in a vacuum, untouched and unobserved. According to quantum mechanics, it exists in a superposition of possible states, but in the real world that electron isn't isolated. It's bombarded by photons, jostled by air molecules, and entangled with countless other particles. This constant interaction with its environment, decoherence theorists argue, is what actually collapses the wave function, not a conscious observer. The universe doesn't wait for us to look, it's too busy talking to itself. Think of it like a drop of ink in a glass of water. At first, the ink stays concentrated, its position clear, but as it spreads, its exact location becomes blurred, not because someone stopped looking, but because the water molecules interact with it, dragging it into irreversibility. Decoherence suggests quantum systems work the same way. The moment a particle interacts with its surroundings, its superposition leaks into the environment, leaving behind the single classical reality we recognize. No consciousness required. The math behind this is staggeringly precise, predicting how quickly superpositions dissolve based on temperature, particle size, and even the type of material nearby. It's a compelling argument, one that removes the need for mystical observers and places the burden of collapse squarely on good old-fashioned physics. But hold on, if decoherence explains everything so neatly, why does the consciousness debate still rage? Because there's a gap, one that even decoherence's staunchest supporters acknowledge. The theory shows how quantum superpositions appear to vanish, but it doesn't fully explain why one outcome emerges over another. Sure, the ink disperses in water, but at some point you still see this particular swirl, not that one. Decoherence describes the process, but it doesn't pinpoint the moment reality chooses its path. That's where consciousness theories push back. Proponents argue that decoherence just kicks the can down the road. If the environment causes collapse, then what collapses the environment's wave function? Eventually, you hit the same problem, an infinite regress of interactions that only stops when someone or something experiences the result. Some scientists, like Roger Penrose, propose a middle ground. He suggests that gravity, not consciousness, might trigger collapse in large systems, but even then, the question lingers, where does experience fit in? The stakes couldn't be higher. If decoherence is correct, then consciousness is a spectator, a beautiful but passive byproduct of physics. But if consciousness plays an active role, then reality isn't just something we measure, it's something we participate in moment by moment. Imagine two scientists measuring the same particle simultaneously from opposite sides of the globe. Decoherence says the particle's state settles the instant it interacts with their equipment. Consciousness theories whisper something wilder. Until their brains process the data, the result might still be up for grabs. This isn't just philosophy. Labs are now testing these ideas with versions of the double-slit experiment where observers range from AI to bacteria to human minds. Early results are provocative. Some studies hint that conscious attention might subtly alter quantum outcomes, while others show no difference at all. The jury's still out, but one thing's clear: the line between observer and observed is blurrier than ever. Whether consciousness collapses reality or simply witnesses it, the universe seems to be playing a far stranger game than we ever imagined. Roger Penrose and Stuart-Hameroff looked at the mystery of consciousness and saw something everyone else missed: tiny structures inside your brain called microtubules. These aren't just cellular scaffolding, they're intricate protein filaments that might be humming with quantum activity. Penrose, a mathematician who reshaped our understanding of black holes and spacetime, teamed up with Hameroff, an anesthesiologist studying how consciousness flickers under sedation. Together, they proposed a theory so bold it stitches quantum physics directly into the fabric of the mind. They call it orchestrated objective reduction, or ORCH for short, and it suggests that consciousness isn't just a byproduct of neurons firing. It's a quantum symphony playing out in the nanoscale tunnels of these microtubules. Here's how it works. Inside every neuron, microtubules act like microscopic computers, processing information in ways far more complex than simple electrical signals. Penrose theorized that these structures could harness quantum superposition, the same blurry state of possibilities seen in particles, to perform calculations classical physics can't explain. But quantum states are fragile. They collapse when disturbed, and that's where consciousness comes in. Penrose argued that these superpositions can't stay suspended forever. Gravity at the tiniest scales destabilizes them, triggering an objective reduction, a moment of collapse that generates a flash of subjective experience. Hameroff added the orchestrated piece, proposing that these collapses aren't random. They're coordinated across vast networks of microtubules, weaving quantum events into the rich tapestry of thought, memory, and awareness you're experiencing right now. Critics pounced fast. The brain, they argued, is too warm, too wet, and too chaotic for delicate quantum states to survive. Decoherence, the same environmental noise that scrambles quantum experiments, would shred these superpositions long before they could influence consciousness. Even staunch quantum physicists raised eyebrows, pointing out that sustaining quantum coherence in biological systems would be like keeping a house of cards standing in a hurricane. But Penrose and Hameroff held their ground. They countered with evidence from an unexpected corner: anesthetics. Hameroff's medical background revealed a curious pattern. Drugs that switch off consciousness, like propofol or xenon, seem to target microtubules, disrupting their quantum vibrations without shutting down overall brain activity. If consciousness were purely a classical process, why would these molecules zero in on structures barely mentioned in traditional neuroscience? The debate took a wild turn when researchers began probing deeper. Some studies found hints of quantum vibrations in microtubules, while others pointed to bizarre effects in photosynthesis, where plants exploit quantum coherence to harvest sunlight with near-perfect efficiency. If nature already uses quantum tricks in green leaves, why not in gray matter? Then came the tubulin proteins, the building blocks of microtubules. Simulations suggested they might switch between states like quantum bits or qubits, processing information in ways that defy classical logic. Even skeptics admit the math is elegant. Penrose's gravitational threshold for collapse, a number so small it's a fraction of a proton's mass, lines up eerily well with the energy fluctuations inside neurons. Yet the biggest hurdle remains experimental proof. How do you measure quantum activity inside a living brain without destroying it? Some teams turn to indirect methods like analyzing brainwaves for signatures of quantum interference. Others proposed using ultra-cold lab-grown microtubules to test coherence times. The results inconclusive but tantalizing. One experiment even suggested that anesthetics reduce the frequency of these predicted quantum collapses, directly linking them to changes in awareness. The urge or theory forces us to confront a staggering possibility that your deepest thoughts might not just feel like quantum leaps, they could be quantum leaps. If Penrose and Hameroff are right, then every decision, every spark of creativity, every moment of aha, is a ripple in the quantum fabric of the universe, orchestrated by the most complex structure we know, the human brain. But if they're wrong, the mystery only deepens, because one thing's certain: whether consciousness bends quantum physics or not, it's bending us toward questions we're only beginning to understand. What if you could reach back in time and change history just by making a choice today? That's the mind-bending premise of delayed choice experiments, where the decisions of an observer don't just shape reality, they seem to rewrite the past. Take John Wheeler's famous thought experiment, a twist on the classic double-slit setup. Imagine a photon racing toward a beam splitter, poised to take one of two paths. Normally, if you measure which path it takes, it acts like a particle. If you don't, it behaves like a wave. But Wheeler asked, what if you wait until after the photon has already passed the splitter, until it's already on its way, to decide whether or not to measure it? The results shouldn't make sense, and yet in lab after lab they do. When physicists actually ran this experiment, something astonishing happened. The photon's behavior retroactively changed based on the observer's later choice. If the scientist decided to measure the path after the photon had already traveled, it collapsed into particle-like behavior. If they chose not to measure, the photon acted as if it had always been a wave, interference pattern and all. It's as if the photon knew in advance what decision the observer would make, rewriting its own history to match. This isn't just quantum weirdness, it's a direct challenge to our everyday understanding of cause and effect. Time, it seems, doesn't flow in one direction at the quantum level. The future might be tugging on the past. Now, scale this up. Imagine a star billions of light years away emitting a photon that, for eons, travels through space as a probability wave. When it finally reaches Earth, an astronomer points a telescope at it. The moment they choose how to observe it, whether to measure its path or its wave-like interference, the photon's entire journey, stretching back across cosmic time, snaps into a definitive state. Wheeler called this the participatory universe, where observation doesn't just record reality but somehow reaches backward to create it. The implications are dizzying. If a choice today can alter what a particle did yesterday, then causality isn't a one-way street. The universe might be more like a tapestry, with threads woven in both directions simultaneously. But how? One interpretation suggests that until an observation happens, all possible histories of a quantum system remain unresolved, floating in a haze of maybes. The observer's decision doesn't change the past so much as select which version of it becomes real. Think of it like a choose-your-own adventure book where the story's ending determines what always happened in earlier chapters. Critics argue this is just a quirk of math, not proof of retrocausality. Yet recent variations of the experiment, like quantum eraser setups, keep reinforcing the same bizarre conclusion. Particles act as if they're in sync with decisions that haven't technically happened yet. The stakes here aren't just philosophical. If consciousness, or even just measurement, can ripple backward through time, then free will takes on a radical new dimension. Are we selecting realities from a menu of possibilities, unaware that our choices echo into the past as much as the future? It's a humbling thought. The universe might not just remember, it might wait, holding its breath until we look before deciding what always was. And if that's true, then every observation you ever make isn't just witnessing history, it's writing it. David Chalmers called it the hard problem, the baffling question of why and how subjective experience even exists. Why does processing information in a brain, no matter how complex, give rise to the vivid inner world you're experiencing right now? The taste of coffee, the sting of a paper cut, the weight of grief, none of these can be explained by neurons alone. Science can map every synapse and still miss the essence of consciousness. But what if the answer isn't hidden in biology alone? What if consciousness isn't something brains produce, but something the universe does, a fundamental feature of reality, as inseparable from physics as space and time? This is where quantum theories take the hard problem and turn it inside out. Think about gravity. You don't ask why mass bends space-time, it's simply how the universe works. Similarly, what if consciousness isn't an emergent property of matter, but a basic force that shapes matter itself? Some physicists now speculate that awareness might be woven into the fabric of reality, as fundamental as charge or spin. Max Tegmark once quipped that if you remove all the space from an atom, you're left with nothing, yet the universe feels solid. Could that feeling be the missing piece? The math hints at eerie possibilities. Quantum mechanics already describes particles as waves of potential until observed. If consciousness collapses these probabilities into reality, then maybe subjective experience isn't a side effect, it's the mechanism. Chalmers himself entertains this idea, suggesting that consciousness could be like dark energy, invisible, omnipresent, and utterly foundational. But here's the catch. Unlike gravity, consciousness resists measurement. You can't put qualia, the raw feel of experience, in a test tube. So how do we test whether it's truly a cosmic force? One clue might lie in the fine-tuning of the universe. The constants of nature, the speed of light, the strength of gravity, are improbably precise for life to exist. Some argue this points to a deeper connection between observers and the observed. If consciousness requires certain physical laws to emerge, maybe those laws emerged because consciousness was already latent, waiting in the equations. It's a loop that makes physicists squirm. The universe seems designed for minds, but minds might be what give the universe its design. Critics dismiss this as circular reasoning, but supporters counter with a provocative thought experiment. Imagine a universe with no observers. Would quantum superpositions ever collapse? Would Schrödinger's cat even need a box? The answer could redefine not just physics, but philosophy. If consciousness is truly fundamental, then every thought you have isn't just a flicker in the dark, it's the universe noticing itself. Imagine a universe where nothing exists outside of perception, no mountains, no stars, no atoms unless a mind perceives them. This isn't science fiction, it's the core claim of philosophical idealism, a view that traces back to thinkers like George Berkeley, who famously declared that to be is to be perceived. Modern idealists like physicist-turned-philosopher Bernardo Kastrup take this even further. They argue that consciousness isn't just a byproduct of the brain, but the fundamental substrate of reality itself. The physical world merely the outside of an inner experience, like the surface of a deeper mental ocean. At first glance, idealism seems light years away from quantum physics. But dig deeper and the parallels are startling. Quantum mechanics already suggests that particles lack definite properties until observed. Idealists simply extend this logic. If observation creates reality at the microscopic level, why not at all levels? Kastrup frames the universe as a sort of dissociated mind, where individual consciousnesses like ours are fragments of a greater universal awareness. The double-slit experiment's wave collapse isn't just a quirk of measurement, it's a glimpse into how mind structures reality. Critics dismiss this as solipsism dressed up in scientific jargon. If the moon only exists when someone looks at it, what about dinosaurs? Did they flicker into being when humans dug up their bones? Idealists counter with a twist. They're not denying the past's reality, just redefining its nature. In their view, the universe's history isn't a fixed timeline but a tapestry of experiences woven by a vast, timeless consciousness. Think of it like a dream. When you wake up, the dream's events feel real and sequential, but they were always just layers of your own mind. The real friction comes when idealism collides with quantum interpretations. Von Neumann's consciousness causes collapse model aligns neatly with Berkeley's old maxim observation, literally summons reality into being. But decoherence theory pushes back, arguing that quantum systems resolve themselves through environmental interaction, no observer required. Idealists reply that decoherence just shifts the question: what constitutes an environment if not a network of conscious interactions? Even the most sterile lab setup ultimately relies on human designers and interpreters. Perhaps the most provocative overlap is in the hard problem of consciousness. Materialists struggle to explain how subjective experience emerges from neurons, while idealists flip the script: matter emerges from experience. Kastrup uses the metaphor of a computer screen. Pixels arrange into images, but the screen itself is the real substrate. Similarly, the physical world might just be the image on the screen of universal consciousness. Quantum weirdness, entanglement, superposition could be artifacts of this deeper unity, like glitches revealing the code beneath the simulation. The debate isn't just academic. If idealism is right, then the search for a theory of everything might need to start not with particles or fields, but with the nature of awareness itself. It's a radical shift, one that blurs the line between physics and metaphysics. But after centuries of treating consciousness as a ghost in the machine, maybe it's time to ask, what if the machine was the ghost all along? What if consciousness isn't something you have, but something the universe is? That's the startling claim of panpsychism, a philosophy that flips the script on everything we assume about awareness. Instead of treating consciousness as a rare byproduct of complex brains, panpsychists propose it's as fundamental to matter as mass or charge. Electrons, atoms, even rocks might possess some dim, primal form of experience, not thoughts or emotions, but an infinitesimal shimmer of subjectivity. At first glance, this sounds like poetic speculation, but when you line it up with quantum theories of consciousness, the parallels start to feel less like coincidence and more like clues to reality's deepest layer. Think of it like this: water is wet, fire is hot. These are intrinsic properties, not things they acquire under the right conditions. Panpsychism suggests consciousness works the same way. It's not magically conjured by neurons, it's baked into the fabric of existence from the ground up. The philosopher Alfred North Whitehead put it beautifully: the universe isn't a collection of objects, but a symphony of experiences, each note, from a quark to a human mind, vibrating with its own tiny pulse of awareness. This isn't about rocks being alive in the way we think of life. It's about recognizing that the boundary between mind and matter might be an illusion. Now connect this to quantum mechanics. If particles exist in superpositions until observed, and panpsychism claims even particles have a whisper of consciousness, then maybe collapse isn't caused by human observers, it's a dialogue between layers of universal awareness. The physicist Freeman Dyson once mused, mind is already inherent in every electron. In this view, the double-slit experiment's wave collapse isn't a special act of human measurement. It's a mundane interaction between one speck of proto-consciousness, the photon, and another, the detector. Consciousness doesn't create reality, it is reality negotiating its own existence moment by moment. But here's where the debates ignite. Critics argue panpsychism swaps one mystery for another. If electrons are conscious, what does that mean? Is there an inner life of a hydrogen atom? Panpsychists reply that we're anthropomorphizing their theory doesn't imply atoms have thoughts, just that experience scales from the microscopic up, like complexity building from simple parts. A neuron isn't aware the way a brain is, but it might contribute a sliver of raw subjectivity that, in aggregate, becomes the rich tapestry of human consciousness. Quantum theories amplify these questions, urge or suggests microtubules harness quantum processes to generate awareness. But if panpsychism is true, then those quantum processes might already be conscious at some rudimentary level. The collapse of the wave function wouldn't need a human observer, just the interplay of countless tiny observers woven into reality's fabric. This bridges the gap between von Neumann's observer-centered quantum mechanics and a universe teeming with micro-experiences. Yet the hard problem lingers. How do billions of atomic-level moments of awareness combine into your seamless stream of thought? This is the combination problem, and it's panpsychism's biggest hurdle. Some theorists propose novel forces or fields that bind these micro-experiences. Others, like philosopher Philip Goff, suggest reality might be more like a vast, unified consciousness that appears fragmented, a cosmic version of how your brain stitches disparate inputs into a single perception. The implications are staggering. If panpsychism meshes with quantum consciousness theories, then the universe isn't just observed, it's observing itself layer by layer, from the flutter of electrons to the gaze of scientists. Your mind isn't an accident in a lifeless cosmos. It's the universe waking up piece by piece to its own existence. And that changes everything, not just how we see reality, but how we see ourselves within it. Not everyone is convinced consciousness holds the reins of reality, far from it. Many mainstream scientists view the idea of mind-collapsing wave functions as little more than wishful thinking dressed in quantum jargon. Take the principle of Occam's razor, which favors simpler explanations over needlessly complex ones. From this perspective, invoking consciousness to explain quantum collapse is like using a flamethrower to light a candle. Why introduce something as nebulous as subjective experience when good old-fashioned physics, like environmental decoherence, already does the job? Critics point to a glaring hole in consciousness-driven theories, the utter lack of direct empirical evidence. Neuroscientists like Patricia Churchland argue that consciousness is entirely a product of the brain's mechanical processes, no quantum magic required. If you alter neural activity with drugs or damage, consciousness changes or fades. No brain, no experience. To claim that awareness somehow reaches out to tweak the fabric of reality, they argue, is to ignore centuries of progress in biology and physics. The burden of proof, they insist, lies squarely on those making the extraordinary claim. Then there's the Wigner's friend problem, but flipped on its head. If consciousness collapses wave functions whose consciousness counts, a cat's, a bacterium's, a supercomputer's, without a clear threshold, the theory risks descending into absurdity. Physicist Sean Carroll has quipped that if consciousness were truly fundamental, we'd see its fingerprints in the equations, but quantum mechanics works perfectly well without ever mentioning it. The math describes particles and fields, not thoughts and feelings. Materialists also highlight a practical concern. If human observers shape reality, what about the billions of years before minds existed? Was the universe a blur of quantum possibilities until the first conscious creature blinked into existence? Critics call this consciousness creationism, a thinly veiled return to pre-scientific myth-making. Even some quantum pioneers like Niels Bohr cautioned against over-interpreting the observer effect. To them, observation simply meant interaction with a measuring device, not a sentient mind. Yet beneath the skepticism lies a deeper tension. Science thrives on testable hypotheses, and consciousness collapse theories often dodge this requirement. How do you design an experiment to prove a thought collapses a wave function? Until someone bridges that gap, the debate remains less a battle of evidence and more a clash of worldviews, one where the mysteries of quantum mechanics meet the even greater enigma of our own inner lives. What if every quantum choice doesn't collapse anything but instead spawns an entirely new universe? That's the spine-tingling proposition of the many worlds interpretation, Hugh Everett's radical answer to the measurement problem. While consciousness-driven models suggest reality snaps into focus when observed, Everett flipped the script. There is no collapse, no observer needed. Every possible quantum outcome plays out just in its own branching timeline. Imagine standing at the quantum crossroads of Schrödinger's cat. Instead of the cat being alive or dead based on observation, the universe splits. In one reality, you open the box to a meowing cat. In another, you're staring at tragedy. Both outcomes are real. Both universes unfold, forever unaware of each other. The elegance of many worlds lies in its simplicity. It treats quantum mechanics like a cosmic choose-your-own-adventure book where every path gets taken. No mysterious collapse, no privileged role for consciousness, just pure, unfiltered math. When a particle's wave function spreads out in superposition, Everett argued, it's not waiting to be observed. It's a signpost pointing to parallel worlds. The double-slit experiment's interference pattern, not proof of wave collapse, but a fingerprint of alternate realities subtly interacting. This isn't science fiction. It's a direct reading of the equations, stripped of extra assumptions. But here's where it collides with consciousness theories. Von Neumann and Wigner saw observation as the knife that cuts reality into definite states. Many worlds says the knife never falls, the cake just keeps dividing. In one universe, you measure an electron spinning up. In another, your doppelganger records it spinning down. There's no you collapsing anything, there's just more yous in more worlds. Critics pounce, if every possibility happens, where's the predictive power? Supporters fire back. The math doesn't prefer one outcome over another anyway. Probabilities aren't about what will happen, but which branch you end up on. The real friction comes when you scale this up. If every quantum event spawns new universes, then every second, reality fractures into trillions of copies. Your morning coffee could have been stirred left or right, creating forks in time too trivial to notice. Consciousness theories call this extravagance. Why infinite worlds when a single conscious observer could do the job? Many worlds retorts. Why invent consciousness as a cosmic referee when the equations work fine without it? Yet both sides share a haunting implication. Reality is far weirder than it seems. Whether it's a universe that splits when you blink or one that waits for your gaze to crystallize, the message is the same. The bedrock of existence isn't solid, it's fluid, malleable, and stranger than our instincts dare admit. The difference is in the storytelling. One casts us as directors shaping the quantum stage. The other makes us audience members, watching a show where every possible scene plays simultaneously in theaters we'll never see. So which is it, a cosmos hinging on perception, or an infinite tapestry of parallel nows? The answer might lie beyond physics in the philosophy of what we're willing to believe. Do we crave a universe that bends to our attention, or one so vast it renders every choice inevitable? Either way, the irony is delicious. The one thing all these theories agree on is that reality, whatever it is, refuses to sit still. Suppose an advanced AI with no subjective experience stares unblinking at a quantum experiment. Does its observation carry the same weight as a human mind's? This isn't just hypothetical. Labs are already using AI to monitor quantum systems, pushing us to ask, can a machine devoid of inner life collapse the wave function? The answer could redefine not just quantum mechanics, but the nature of consciousness itself. Consider AlphaFold, Google DeepMind's protein folding AI. It predicts molecular structures with uncanny accuracy, yet no one claims it understands biology. Similarly, an AI tracking qubits in a quantum processor might record data flawlessly, but does its observation force superposition into a single state? Proponents of consciousness-driven collapse argue no. They compare AI to a camera. It captures information, but without subjective experience. It's just another link in the chain. The wave function, they insist, only collapses when encountering phenomenal awareness, the raw, what it feels like to be something. An AI, no matter how sophisticated, lacks that qualia. Yet others counter with a brutal pragmatism. If consciousness is irrelevant to collapse, if all that matters is information becoming classical through interaction, then AI observers should work just fine. After all, quantum decoherence theory already removes the need for minds, emphasizing environmental interactions. In this view, an AI's detectors are no different from Geiger counters or photographic plates. The universe doesn't care who or what observes, only that information becomes irreversibly recorded. The stakes escalate when we imagine AI-designed quantum experiments. Picture a self-improving algorithm that iteratively adjusts measurement protocols without human input. If its choices alter quantum outcomes, does that imply a new kind of machine agency? Philosopher David Chalmers toys with this idea, suggesting that if an AI ever achieved genuine consciousness, say, through artificial microtubules or quantum processes, it might not just record reality but participate in its creation. The irony is delicious. The very machines built to probe quantum mysteries could become central actors in them. Now, zoom out to quantum computing's future. These machines rely on qubits existing in superposition to perform calculations. If consciousness does play a role in collapse, then human engineers peering at qubit readouts might inadvertently disrupt the quantum states they're trying to harness. But if AI observers don't trigger collapse, they could become ideal quantum custodians, silent, stable, and free from the observer effect. Some labs are already testing this, using AI to optimize quantum error correction without human interference. Early data hints at subtle differences in qubit stability when AI handles measurements versus human-monitored runs. Yet the darkest twist lies in the hard problem. If we one day build an AI that claims to be conscious, how would we know? Current tests, like the Turing test, focus on behavior, not inner experience. An AI could recite poetry about sunsets without ever feeling warmth or color. But if that same AI starts influencing quantum systems in ways that align with conscious observation theories, we'd face a profound dilemma. Either consciousness isn't necessary for collapse, or the machine is more aware than we imagined. This convergence of AI and quantum physics doesn't just challenge our tools. It forces us to confront the murky boundary between measurement and meaning. Whether silicon or synapses hold the power to shape reality, one thing's clear: the age of passive observation is over. We're no longer just peering into the quantum abyss. We're teaching our creations to peer with us, and the abyss might be peering back. What if the quietest moments of your mind, those deep, meditative states, held the key to bending reality itself? Scientists are now exploring a provocative idea that trained meditators might literally perceive the world differently, not just psychologically but at the quantum level. A groundbreaking study at Princeton University suggests something extraordinary. When experienced meditators focused their attention on a double-slit experiment, the same test that reveals quantum particles behaving as waves, the interference pattern, that hallmark of quantum weirdness, showed subtle but measurable shifts. It's as if their concentrated awareness reached into the quantum haze and nudged it ever so slightly toward order. This isn't mystical guessing. The study built on decades of research into how consciousness interacts with physical systems. The famed Pear Lab at Princeton spent 30 years documenting how human intention could influence random number generators, machines designed to spit out purely chaotic sequences. The effects were tiny but statistically significant, like a whisper pushing against the wind. Now imagine amplifying that whisper through meditation. Tibetan monks, for instance, can enter states of such profound focus that their brainwaves synchronize in ways Western science struggles to explain. When these monks participated in intention-based experiments, the results weren't just anomalies. They hinted at a latent ability to harmonize with quantum unpredictability. Skeptics, of course, raise eyebrows. Couldn't these findings be flukes or the result of subconscious biases in data collection? After all, quantum effects are notoriously delicate, easily drowned out by environmental noise. But proponents counter with an elegant point. Meditation doesn't just calm the mind, it might temporarily simplify it. Think of a cluttered room. The more objects there are, the harder it is to find what you need. Similarly, a busy, distracted brain could be less effective at influencing quantum systems than one honed to laser-like clarity. In this view, meditation isn't magic. It's a tool for reducing mental decoherence, quieting the internal noise that usually scatters our observational power. The implications ripple far beyond labs. If focused awareness can tangibly interact with quantum systems, what does that mean for our daily lives? Consider the placebo effect, where belief alone triggers real physiological healing. Could this be a macroscopic echo of quantum observation, a mind collapsing not just wave functions, but biochemical possibilities into reality? Or take intuition. Those moments when you know something without knowing how. Some researchers speculate this could be the brain tapping into quantum probabilities, perceiving outcomes before they've classically happened. Yet the most tantalizing question remains unanswered. Is meditation revealing a hidden link between consciousness and quantum mechanics, or is it simply exposing the limits of our current models? Physics has always progressed by confronting the unexplainable. Maybe the act of looking inward, of refining perception itself, isn't just philosophical exercise. Maybe it's the next frontier of empirical discovery. After all, if a quiet mind can change what it observes, then the universe might be far more responsive than we ever dared dream. A man lies motionless on a hospital bed, his heart silent for minutes as doctors scramble to revive him. Then suddenly, he gasps back to life. What he describes next shatters conventional understanding. A tunnel of light, a review of his life's memories, conversations with entities unseen. These aren't hallucinations, he insists. They feel more real than reality itself. Near-death experiences, or ND, have been reported across cultures for centuries, but modern science still grapples with their implications. Could these vivid journeys hint at consciousness operating beyond the brain, perhaps even influencing the fabric of reality like a quantum observer? Consider the striking parallels. Just as particles exist in superposition until observed, some ND survivors describe existing in multiple states, simultaneously watching their own bodies from above while simultaneously sensing distant locations. In one documented case, a cardiac arrest patient accurately recounted conversations happening 3 rooms away from their unconscious body, later verified by witnesses. Skeptics dismiss this as coincidence or oxygen deprivation, but researchers like Dr. Bruce Grayson have catalogued too many precise, verifiable details to ignore. If consciousness can perceive events beyond the brain's physical limits, does that mean it's not bound by them? The deeper mystery lies in ND's transformative power. Survivors often return with altered personalities, less materialistic, more empathetic, as if their brush with death collapsed not just their biology but their identity's wave function. One woman described her experience as waking from a dream into true reality, echoing the quantum notion that observation selects one possibility from many. Even more startling are shared death experiences, where bystanders report seeing the same visions as the dying person, a collective collapse of perception that defies classical explanation. Quantum theories offer a provocative lens. If consciousness shapes reality at microscopic scales, could extreme states like near-death amplify this effect? The renowned physicist Sir Roger Penrose speculated that NDEs might involve quantum processes momentarily decoupling from the brain's physical structure, accessing a broader field of potential states. It's a radical idea that dying could briefly free consciousness to interact with reality's underlying quantum code, unshackled from biological constraints. Yet the debate rages. Materialists argue NDEs are just the brain's last fireworks, a surge of DMT or neuronal chaos. But this fails to explain how oxygen-starved brains produce hyperlucid experiences richer than normal consciousness. Meanwhile, studies on terminal lucidity, where dementia patients suddenly regain clarity moments before death, hint at consciousness operating independently of brain degradation. The truth might lie somewhere in between. Perhaps NDEs don't prove consciousness collapses reality, but they force us to ask what reality is when consciousness persists beyond the body's apparent shutdown. If a dying mind can still observe, then observation might not require a living brain at all. And that opens a door science is only beginning to knock on, one where the line between observer and universe blurs into something far stranger than we ever imagined. Imagine two particles separated by vast distances, light years apart, yet instantly mirroring each other's movements. This is quantum entanglement, a phenomenon Einstein called spooky action at a distance. Now stretch that idea to human minds. What if the same invisible threads binding particles could also link thoughts across space? It sounds like telepathy, the stuff of sci-fi and seances. But a small cotter of scientists is daring to ask, could entanglement explain psychic phenomena? The data is contentious, the experiments often dismissed as fringe, but the questions they raise cut to the heart of reality's deepest mysteries. Take the work of physicist Helmut Schmidt in the 1970s. He built a machine that generated random numbers using radioactive decay, a quantum process. Volunteers were asked to mentally influence the outcomes, nudging the randomness toward patterns. Against all odds, some subjects consistently produced slight but statistically significant deviations from chance. Skeptics cried foul, citing flawed methodology or selective reporting. Yet similar results emerged in meta-analyses of later studies, including those at Princeton's Pear Lab. The effects were tiny, but they flickered like distant stars in otherwise predictable data. The controversy deepens with experiments in distant mental interaction. In one setup, pairs of emotionally connected people twins, spouses, were isolated in separate rooms, hooked to EEG monitors. One was shown flashes of light or disturbing images, while the other's brainwaves were recorded. In some trials, the unstimulated partner's brain showed synchronized activity before the other was exposed, as if picking up a signal with no classical explanation. Mainstream neuroscience scoffs, attributing this to coincidence or experimental noise, but quantum enthusiasts whisper, could entangled particles in their brains have momentarily bypassed space and time? The parallels are tantalizing. Entanglement defies locality, the rule that objects can't influence each other faster than light. Telepathy, if real, would smash that same barrier. Both phenomena hinge on inexplicable correlations, particles spinning in unison, minds echoing unspoken thoughts. Even the math hints at overlap. Some theorists propose that microtubules in neurons, those same structures Penrose and Hameroff linked to quantum consciousness, might harbor entangled states, creating a biological substrate for psi. It's a wild leap, but not an impossible one. After all, photosynthesis exploits quantum coherence in plants. Why not brains? Yet the scientific establishment remains unmoved. Critics argue that quantum effects decohere too quickly in warm, wet brains to sustain entanglement. They point to the cheetah detection problem. If telepathy were real, evolution would have weaponized it for survival, leaving unambiguous evidence. And then there's the replication crisis. Few psi studies withstand rigorous retesting. Dean Radin of the Institute of Noetic Sciences counters that skepticism itself may be the hurdle. He cites experimenter effects. where researchers' disbelief statistically dampens results, echoing the observer effect in quantum mechanics, a self-fulfilling prophecy of doubt. The boldest claim comes from those bridging quantum biology and psi. Could entanglement create a hidden network of consciousness, a cosmic web where minds briefly sync? Imagine a global telepathy field where intentions resonate like vibrating strings. It's a poetic idea, but even proponents admit the evidence is circumstantial. Yet history teaches us that today's heresy sometimes becomes tomorrow's science. Quantum mechanics itself was once dismissed as mystical nonsense, so where does this leave us? In a gray zone between provocation and proof, the links between entanglement and telepathy remain speculative, a playground for mavericks and mystics. But the questions they raise about consciousness, connectivity, and the limits of materialism refuse to fade. Whether psi is quantum's shadow or just a trick of the light, it forces us to confront an unsettling truth. The universe might be far stranger and far more interconnected than our textbooks dare admit. And sometimes the most radical ideas are the ones that push science forward. Could the universe itself be conscious, a vast, thinking entity where galaxies and atoms hum with the same primordial awareness that flickers in our own minds? Biocentrism, championed by scientist Robert Lanza, takes this idea to its grandest scale. He proposes that consciousness isn't just a product of the universe, it's the very foundation of reality. Without it, space, time, and matter would dissolve into a featureless haze of probabilities. Think of it like a cosmic version of the observer effect. The universe isn't just seen into existence by minds like ours, it requires observation to exist at all. Lanza's biocentric universe doesn't have stars and planets floating in empty space, it's a web of relationships where life and awareness are the threads holding reality together. Lee Smolin, a physicist who shaped loop quantum gravity, offers a different but equally radical twist. His cosmological natural selection theory suggests universes evolve like life forms, with black holes birthing new ones. But here's the kicker: if universes can evolve, could they also develop a form of consciousness? Smolin doesn't outright claim the cosmos is self-aware, but he leaves the door wide open. Picture a universe fine-tuning its own laws over eons, not through random chance, but through a kind of cosmic trial and error, a process eerily reminiscent of learning. If that's true, then quantum collapse might not be a local event tied to human brains, but a universal habit, a reflex woven into the fabric of space-time itself. Now scale this up. If cosmic consciousness exists, how would it think? Unlike human minds, bound by neurons and seconds, a universe-scale awareness would operate on a canvas of billions of years. Its thoughts might look like the birth and death of stars, the dance of dark matter, or even the emergence of life, a slow, stately unfolding of self-reflection. Philosopher Bernardo Kastrup likens it to a dreamer whose dream includes smaller dreamers nested within it. Our individual consciousnesses, then, could be fragments of this greater mind, temporary eddies in a river of universal awareness. The implications for quantum mechanics are staggering. If the cosmos is fundamentally conscious, then wave function collapse isn't triggered by human observation alone. It's the universe observing itself. Every particle's leap from possibility to reality would be a flicker of cosmic attention, a moment where the whole system adjusts its own state. This would explain why quantum effects persist at vast scales in places like neutron stars or interstellar clouds. There's no outside observer needed when the universe is both the experiment and the experimenter. Critics, of course, bristle at this leap. They argue that attributing consciousness to the universe is a modern spin on pantheism, a scientific veneer over ancient mysticism. Without a mechanism to explain how cosmic awareness arises, they say, the theory remains poetic speculation. But supporters counter with a provocative question. If human consciousness can collapse quantum states, why assume it's the only thing that can? If the universe is a single, entangled system, then every act of observation, whether by a human, a crow, or a collapsing star, might be part of the same participatory dance. The debate touches something primal. For centuries, we've framed reality as a cold, clockwork machine. But what if it's more like a living thought? A universe that observes itself isn't just stranger than we imagine, it's stranger than we can imagine. And if that's true, then the real mystery isn't whether the cosmos is conscious. It's whether we're just beginning to wake up to the fact that we've been part of its mind all along. If consciousness truly shapes reality, then every thought we entertain becomes more than just a fleeting moment. It transforms into a brushstroke on the canvas of existence. This isn't just philosophy, it's a staggering ethical responsibility. Take the concept of manifestation, popularized by self-help movements. The idea that focused intention can attract specific outcomes aligns eerily with quantum theories of observation. But if our minds nudge probabilities into being, what happens when billions of people manifest conflicting realities? One person visualizes wealth while another dwells in scarcity. Does the universe split the difference, or do some intentions carry more weight? The ethical weight of this question is crushing. If observation creates, then indifference becomes a form of negligence. Ignoring suffering isn't just passive, it might reinforce its existence in the quantum tapestry. Now zoom out to collective intent. History brims with moments where shared belief seemed to bend reality. Mass meditations linked to reduced crime rates, the placebo effect scaling to entire communities during healing rituals. In a conscious universe, these aren't coincidences, they're glimpses of synchronized observation in action. Imagine a stadium of fans willing their team to victory. Could the sheer density of focused attention tip quantum probabilities toward a winning goal? Experiments like the Global Consciousness Project, which tracks random number generators during global events, hint at anomalies during moments of mass emotion. Whether it's the solidarity of a protest or the terror of a crisis, collective consciousness might be the universe's most potent force, for better or worse. But power demands accountability. If observing a particle collapses its state, what collapses when we observe injustice? Turning away from systemic inequality isn't just moral failure, it's a refusal to measure the problem into resolution. This reframes activism as quantum intervention, bringing hidden superpositions of justice into sharp, undeniable focus. Yet the flip side is darker. Surveillance capitalism exploits this principle daily. Every click, every scroll is a micro-observation that reinforces algorithmic realities. When tech platforms amplify outrage or conspiracy theories, they're not just holding up a mirror, they're collapsing wave functions into ever more polarized worlds. The most haunting implication lies in unobserved suffering. If a tree falling unheard stays in quantum limbo, what of pain witnessed by no one? Solitary prisoners, trafficked individuals, dying species. Are they suspended in a hell of uncollapsed possibilities until attention finds them? This isn't metaphor. Quantum ethics would demand we bear witness relentlessly, not just for moral clarity, but to make suffering real enough to change. Here's the paradox. If reality is participatory, then passivity is a myth. You're either shaping existence or ceding that power to others. The universe might not care whether we manifest wisely or recklessly, but the consequences will echo through the quantum weave all the same. The real question isn't whether consciousness creates, it's what kind of creators we choose to be. Plants don't have brains, yet they perform quantum calculations with precision that would make a supercomputer jealous. Take photosynthesis, nature's most efficient solar energy system. When sunlight hits a leaf, its energy doesn't bounce around randomly until it finds the reaction center where photosynthesis happens. Instead, experiments reveal something astonishing. The energy travels multiple paths simultaneously, as if testing all possible routes before choosing the most efficient one. This isn't just chemistry, it's quantum coherence in action, with particles behaving like waves to optimize energy transfer. If human engineers could mimic this process, solar panels would become nearly 100% efficient overnight. But here's the real mystery. These quantum effects persist in warm, wet, chaotic cellular environments, conditions where lab-grown quantum systems typically collapse in femtosecond. How do plants maintain this delicate quantum dance without decoherence shredding it apart? Some scientists speculate that life itself might be the missing ingredient, as if biology has evolved to harness quantum weirdness rather than fight it. Now shift your gaze skyward to the humble robin. Every year, these birds navigate thousands of miles using Earth's magnetic field, a feat that baffled scientists for decades. The leading theory, quantum entanglement in their eyes. Researchers found cryptochrome proteins in avian retinas that react to magnetic fields, relying on entangled electron pairs to act as a biological compass. When light hits these proteins, it creates radical pairs, molecules with unpaired electrons whose spins are entangled. Earth's magnetic field subtly alters these spins, giving the bird a quantum-enhanced sense of direction. Unlike human-made quantum sensors, which require frigid temperatures and isolation, robins perform this trick while flying through storms, dodging predators, and singing mid-flight. It's as if their biology has cracked a code we're still fumbling to decipher: how to keep quantum systems stable in the noisy real world. But this raises a provocative question. If plants and birds exploit quantum mechanics without brains, does that mean consciousness, at least in some rudimentary form, is woven into life itself? Philosopher David Chalmers once pondered whether a thermostat could be conscious, suggesting that experience might scale from simple to complex. In that light, could photosynthesis be a kind of plant-level observation, a primitive act of quantum decision-making? The idea sounds outlandish until you consider slime molds, brainless organisms that solve mazes and anticipate periodic events, or bacteria that use quantum tunneling to accelerate mutations when stressed, effectively choosing evolutionary path. These aren't thought processes as we know them, but they hint at a gray zone where biology blurs into observation-like behavior. Critics fire back with Occam's razor. Just because life uses quantum effects doesn't mean it's conscious of them. A sunflower tracking the sun isn't making choices, it's following biochemical algorithms. But supporters counter with a twist: what if consciousness is an algorithm? Or theories microtubules suggest that even neurons might rely on quantum processes. If that's true, then the leap from bird navigation to human awareness could be a matter of degree, not kind. The implications ripple far beyond biology. If nature is full of quantum observers, then the universe might be far more awake than we ever imagined. From migrating butterflies to algae optimizing light absorption, life could be participating in reality's construction at scales we're only beginning to glimpse. This isn't about attributing human-like thoughts to plants. It's about recognizing that the line between observer and observed might not be a wall, but a spectrum. And somewhere on that spectrum, between the flutter of a leaf and the spark of human insight, reality might be holding its breath, waiting to be seen. Imagine a device that doesn't just read your thoughts, it responds to them, instantly shaping the physical world. This isn't telekinesis, it's the cutting edge of quantum sensor technology, where the boundaries between mind and matter are dissolving. Researchers are already developing systems that harness the faintest whispers of mental focus to influence quantum states, blurring the line between observer and tool. Take, for instance, the latest breakthroughs in magnetoencephalography, or MEG. These brain-scanning devices detect the magnetic fields generated by neural activity with such precision that they can pinpoint a single thought's origin. Now pair that with a quantum sensor, a device so sensitive it can measure the spin of an individual electron. Suddenly, the act of concentration alone might nudge quantum probabilities, tweaking the sensor's output in real time. Early experiments hint at this possibility, with subjects subtly altering quantum random number generators through focused intent, as if their awareness is a gentle hand tilting the cosmic scales. The implications for control systems are staggering. Picture a surgeon guiding microscopic nanobots through your bloodstream using nothing but thought, their paths directed by the quantum collapse triggered by her attention. Or imagine architects designing buildings where ambient lighting and temperature adjust seamlessly to occupants' unspoken preferences, their desires etched into reality by quantum-responsive materials. These aren't distant fantasies. Companies like Google and IBM are already investing in brain-computer interfaces that leverage quantum principles, merging neural signals with qubit arrays to create systems where thought equals action at the speed of perception. Yet the most revolutionary application lies in communication. Quantum entanglement allows particles to share information instantaneously across distances. If human consciousness can influence one half of an entangled pair, could we encode thoughts directly into matter? Pioneering work at the University of Geneva suggests it's not impossible. In their setup, participants focused on specific mental states while observing entangled photons. The correlated photons showed statistically anomalous alignments with the subject's intentions, as if the observers' minds were whispering to the quantum void, and the void whispered back. Skeptics dismiss it as statistical noise, but if replicated, this could birth a new era of quantum telepathy, where minds converse through the silent language of collapsed wave functions. Of course, the hurdles are immense. Decoherence remains the nemesis of quantum systems, and the brain's wet, warm environment is a hostile place for delicate superpositions. But nature might hold the key. Just as plants sustain quantum coherence in sunlight, future biohybrid devices could integrate living neurons with quantum circuits, using biological structures to stabilize the fragile dance of probabilities. The fusion of organic and artificial observation could redefine what it means to interact with technology, turning every glance, every thought into a creative act that molds reality at its roots. The ultimate dream, a world where devices don't just respond to commands but anticipate needs by tapping into the quantum undercurrent of consciousness itself. Your smartphone might sense frustration before you do, adjusting its interface to calm you. A car could detect drowsiness the moment it flickers at the edge of awareness, steering you safely home. This isn't just convenience, it's symbiosis, a future where the boundary between tool and user fades into the quantum foam, leaving only the pure interplay of mind and matter. And if that sounds like magic, remember, every transformative technology begins as an impossibility until someone observes it into existence. What if everything in the universe behaved exactly as it does now, atoms colliding, stars burning, planets orbiting, but no one was actually experiencing any of it? No joy, no pain, no color, no sound, just empty, flawless machinery ticking away in the dark. Philosophers call this haunting thought experiment the P-zombie, problem short for philosophical zombie. A P-zombie walks, talks, and even claims to feel love or grief, but inside there's nothing. No inner light, no private movie of the mind. It's a perfect imitation of consciousness without the actual consciousness. Now stretch that idea to the cosmos. Could reality exist as a vast, intricate dance of particles, utterly devoid of what neuroscientists call P-consciousness, the raw, felt quality of experience? This cuts to the heart of a fiery debate. On one side, materialists argue that consciousness is just a sophisticated byproduct of information processing, like smoke from a fire. In their view, a universe without observers would hum along just fine, full of complex systems doing their thing, none of them ever feeling a thing. The double-slit experiment's wave collapses, just environmental decoherence at work, no inner awareness needed. But on the other side, idealists and panpsychists counter with a bombshell. Without P-consciousness, there's no reason for anything to appear at all. A camera records data without experiencing it, but the universe isn't a camera. The very fact that reality manifests that there's a there suggests something deeper is at play. Here's the twist: even in quantum physics, the math doesn't demand an observer with P consciousness. A photon doesn't care whether it's seen by a human eye or a silicon chip. But the results of observation, the crisp, classical world we perceive, are inexplicable without something to witness the collapse. Think of it like a theater with no audience. The play could still run, lines delivered to empty seats, but if no one's there to experience it, does the performance have any meaning? Or does it remain suspended in potential, like Schrödinger's cat forever unobserved in its box? The P-consciousness distinction exposes a rift in how we define reality. Information processing is everywhere. Your laptop does it, a sunflower tracking the sun does it. But P-consciousness, that's the hard problem. A computer can calculate the color red by processing wavelengths, but it doesn't see red. If the universe is just information processing, then P-zombies aren't just possible, they're inevitable. But if P-consciousness is fundamental, woven into the fabric of existence like gravity, then a zombie universe isn't just unlikely, it's a logical contradiction. Reality requires observers because observation is what breathes it into being. Critics dismiss this as circular reasoning. They point to anesthesia, turn off a brain's processing, and consciousness winks out. But supporters fire back with near-death experiences, moments when brains show minimal activity, yet people report hyperreal awareness. The truth might lie in the gray zone. Maybe P-consciousness isn't binary but spectral, flickering in degrees across the cosmos. A bee's awareness of sunlight, a crow's recognition of its reflection, the eerie problem-solving of slime mold, each could be rungs on a vast ladder of experience. The stakes couldn't be higher. If P-consciousness is optional, then we're cosmic accidents, ephemeral sparks in a dead machine. But if it's fundamental, then the universe isn't just here, it's awake. And that changes everything. From the quantum foam to the glow of galaxies, reality might not just be something we observe. It might be something we answer to, moment by moment, with every breath of awareness. Long before quantum physics grappled with the observer effect, ancient traditions were weaving strikingly similar ideas into their understanding of reality. Take the Hindu concept of Maya, the illusion that the material world is the ultimate truth. The Upanishads, written over 2,000 years ago, describe reality as a projection of Brahman, the universal consciousness, much like a quantum wave function awaiting collapse. The world we perceive isn't an independent, solid thing, they taught, but a shimmering veil shaped by perception. The Buddhist mind-only philosophy takes this further, asserting that all phenomena arise from consciousness itself. Texts like the Lankavatara Sutra declare that objects have no inherent existence outside the mind, observing them an eerie parallel to modern debates over whether particles exist before measurement. These traditions didn't stop at metaphysics. They developed rigorous practices to test their claims. Yogic meditation, for instance, trains practitioners to dissociate from sensory input, effectively unobserving the world to glimpse the underlying void. Tibetan monks skilled in dream yoga report manipulating dream objects at will, a personal scale demonstration of how intention might shape reality. Even the Taoist idea of wu-wei, or effortless action, mirrors the quantum principle that observation disturbs the system. By minimizing interference, the adept aligns with the natural flow, much like a physicist careful not to collapse a superposition prematurely. Jump to ancient Greece, and you'll find Protagoras declaring, "Man is the measure of all things," while Plato's allegory of the cave framed perception as shadows on a wall. These weren't poetic musings, they were early attempts to reconcile the gap between appearance and reality. Compare this to quantum pioneer Niels Bohr's insistence that nothing exists until it is measured, and the through line becomes undeniable. Indigenous cultures add another layer, the Maori concept of whakapapa, binds all existence into a single, interconnected web, where observation isn't passive but an active relationship echoing quantum entanglement's spooky kinship across distance. The critical divergence lies in methodology. Ancient traditions relied on introspective techniques honed over lifetimes to probe consciousness's role in shaping reality. Modern science demands reproducible experiments and falsifiable claims, yet both converge on a startling possibility that the universe isn't just out there waiting to be discovered. It's in here waiting to be decided. Whether through the lens of Vedantic sages or quantum physicists, reality seems to be less a fixed stage and more an ongoing conversation, one where the observer isn't just a spectator, but a participant with skin in the game. This isn't to say ancient wisdom predicted quantum theory. Rather, it highlights how deeply the intuition of a participatory universe is woven into human thought. From the mandalas of Tibetan Buddhism to the equations of Heisenberg, we've always sensed that to look is to touch, and to touch is to change. The difference now. We're building machines to prove it. How do we test whether consciousness wields power over the quantum world? The answer lies in experiments so precise they border on science fiction. Picture a lab where quantum systems are monitored side by side, some watched by humans, others by AI, and some left entirely unobserved. The goal: to catch reality in the act of choosing its state and see if the presence of a conscious mind tips the scales. One such setup could involve a modified double-slit experiment, where photons are fired toward a detector capable of recording their wave-like or particle-like behavior. But here's the twist. The decision to observe or not observe isn't made by a scientist in real time. It's randomized by a quantum process itself, ensuring no human bias contaminates the results. If the photons consistently behave differently when human observers are present versus when AI or no observers monitor them, it could suggest consciousness plays a unique role in collapse. Another provocative idea involves blind observation. Imagine a quantum random number generator producing outputs that determine whether a measurement is taken, but the results are only revealed to a human observer after a delay. If the system's behavior retroactively aligns with the eventual observation, as if the future act of conscious perception reached back to influence past events, it would echo John Wheeler's delayed choice experiments on a grander scale. This wouldn't just test consciousness collapse theories, it would challenge our understanding of time itself. Then there's the realm of collective intention. Researchers could gather hundreds of meditators to focus their attention on a quantum system simultaneously, aiming to shift its statistical behavior beyond chance. Early attempts like the Princeton pair experiments hinted at subtle effects, but modern labs could scale this up with ultra-sensitive qubit arrays. If synchronized mental focus reliably alters quantum outcomes, it would suggest consciousness isn't just a passive witness but an active participant in reality's construction. But the most radical proposal, a Wigner's friend experiment made real: two isolated observers, one inside a quantum-sealed chamber, the other outside, monitor the same system. If the external observer's measurements conflict with the internal observer's records, it would imply reality isn't just observer-dependent but fractured, with each consciousness carving its own truth from the quantum foam. The implications would rattle physics to its core, forcing us to ask, if no two observers share the same reality, what does that mean for our collective world? The road ahead is fraught with challenges. Decoherence, noise, and the sheer fragility of quantum states make these experiments fiendishly difficult. Yet if even one succeeds, the payoff would be unimaginable. We'd no longer be mere spectators of the universe, we'd be co-authors, wielding the pen of perception to write the next chapter of existence. And that's a power we'd need to wield wisely. If consciousness truly holds the power to collapse quantum probabilities into reality, then every choice we make isn't just a reaction, it's an act of creation. Think about the last decision you wrestled with, whether it was what to eat for breakfast or a life-altering career move. In a deterministic universe, those choices might be illusions, predestined by the unbroken chain of cause and effect. But quantum mechanics introduces a crack in that chain, an inherent unpredictability at the heart of matter. If our awareness taps into that indeterminacy, then free will isn't just possible, it's woven into the fabric of existence itself. Consider Schrödinger's cat once more, suspended between life and death until observed. Now, replace the box with your own mind. Every decision you face exists in a superposition of possibilities, a mental wave function of coulds and might best. The moment you commit to one option, you're not just observing an outcome, you're collapsing your own future into being. This isn't about controlling external events like a comic book telekinetic. It's about the subtle, daily alchemy where attention shapes probability. The job you apply for, the conversation you initiate, even the thoughts you dwell on each could be a conscious nudge to the quantum dice. But here's the catch: quantum indeterminacy doesn't guarantee control, it just injects uncertainty. A roulette wheel's spin is unpredictable, but that doesn't mean you can mentally land the ball on your chosen number. Similarly, if consciousness collapses wave functions, the scope of that influence remains fiercely debated. Some argue it's limited to the microscopic tiny fluctuations that ripple up into macro-scale effects over time. Others, like physicist Henry Stapp, propose that the brain's quantum processes amplify these collapses, making human intention a legitimate force in navigating probabilistic futures. The tension lies in reconciling this with neuroscience, where brain activity often precedes conscious choice by milliseconds. Experiments like Libet's famous readiness potential study suggest decisions are made subconsciously before we're aware of them. But quantum advocates counter with a loophole. What if those neural signals aren't deterministic commands, but probability superpositions awaiting conscious ratification? In this view, free will isn't about initiating actions from scratch, but steering them at the quantum level, like a kayaker nudging their course through a rapid's chaos. Critics dismiss this as wishful thinking, insisting that quantum effects are too fragile to influence the brain's wet, noisy environment. Yet life itself thrives on improbabilities. A single photon triggering vision, a mutation-altering evolution, tiny quantum events can cascade into Chinese letter consequences. If consciousness harnesses these moments, even imperfectly, then free will might not be an all-or-nothing phenomenon, but a matter of degree. You're not a puppet master pulling reality's strings. You're a participant in a dance where every step, every observation tilts the odds. The ethical weight of this is staggering. If choices shape reality, then apathy isn't neutral, it's a surrender of agency. But the inverse is also true. Every act of focused intention, from personal goals to collective movements, becomes a creative force. Whether quantum mechanics validates free will or not, the feeling of choice is undeniable. And in a universe where observation might shape existence, that feeling could be the most real thing of all. From the dizzying heights of quantum labs to the cosmic depths of universal consciousness, we've traced a thread that defies intuition at every turn. We've watched particles exist in multiple places at once until a conscious gaze forces them to choose. We've seen ancient philosophies whisper truths that modern science is only now beginning to echo. We've even glimpsed the audacious idea that reality itself might be less like a machine and more like a living thought, a vast, shimmering possibility waiting for minds like ours to bring it into focus. But here's the lingering question, the one that refuses to dissolve into the quantum haze. What does it all mean for us? If consciousness truly plays a role in shaping the universe, then every moment of attention becomes a creative act. Your focus isn't just noticing the world, it might be sculpting it in ways both subtle and profound. On the flip side, if the universe unfolds with or without us, indifferent to our observations, then we're spectators in a drama far grander than our fleeting lives. The beauty of this journey isn't in the answers, it's in the questions themselves. Whether we're active participants in reality's unfolding or simply along for the ride, one thing is certain. The universe is far stranger, far more mysterious, and far more wondrous than our ancestors ever dreamed. And that's what makes this exploration so thrilling. We're not just studying the cosmos, we're part of it, entangled in its mysteries in ways we're only beginning to grasp. So what do you think? Does consciousness reach into the quantum world, coaxing reality into being? Or are we just witnesses to a show that would go on without us? Drop your thoughts in the comments. Let's keep this mind-bending conversation going. And if you loved this deep dive into the fabric of existence, don't forget to subscribe. The universe is full of mysteries, and we're just getting started.